Hi guys, let's take a look at this problem. So we know a woman walks towards a straight line, and then the height of straight line and this woman also given. We want to find the rate of change of the length of her shadow when she's 11 feet from the straight line, and what rate is the tip of her shadow moving. So we have several problems here. So the first thing that I would like to do is always draw a picture that can model this scenario, right? So let's draw that. So suppose this represents the straight line. It is 22 feet tall, and then a woman is walking towards this one, and it's about 11 away, right? 11 feet away. So let's, according to the problem, we want to let x be the woman's distance from the straight line. L is the distance, the length of woman's shadow. So in other words, let's call this as x. And so this woman is about 5.5 foot tall. So this represents her height. And the light casts a shade here. So the problem says let's define this distance as L. This is L, and this distance is x. Now we want to find what rate of the change of the length of a shadow. So according to the label that we have, we actually want to find dLdt, right? And then when x is 11 feet away from the light. So this is what we know. And this woman is 5.5 foot tall. Now, another thing that the second question is, at what rate is the tip of her shadow moving? So this is the tip. This is the tip of her shadow. So when she walks towards the straight line, this tip of her shadow also moves towards here, towards the straight line. So basically, I'm gonna, if I call this distance from the tip of her head, of the shadow, not her head, but the tip of the shadow to the the location of the straight line, let's call this as W. We also want to find the dW, so and dW dt, right? So this is the tip of her shadow. All right, let's see how do we solve this problem. First of all, I'm gonna find a relationship that relates these variables together and the numbers. So one thing that we do know is, because these two, the woman and the straight lines, they are vertical, so they're parallel lines. These two are parallel lines, and therefore this small triangle should be similar to the larger triangle. Because they're similar, the corresponding sides should be proportional. So in other words, this is what we are going to do. The L of the smaller triangle, which is this length, over the corresponding side of the larger triangle, which is this length, right? This length, which is L plus X, should be equal to this length of the smaller triangle over this side of the larger triangle, so which is equal to 5.5 over 22. If you do this algebra, isn't that 1/4? And then based on this equation right here, we have we can see that 4L equals L plus X, right? After some algebra, you're going to multiply, cross multiply. So 4 times L equals L plus X times 1. That's what we have. Or this means 3L equals x. So this is what we know. Now, we do know that this woman walks 5 feet per second towards the straight line. In other words, dx dt should be equal to 5 feet per second. Because this x distance is decreasing, actually we want to add a negative sign just because of that reason. Now, if you look at what we have, so we have dx dt, we want to find dl dt, and this is the relation that we just found. So I would like to differentiate both sides with respect to t so that I can create dl dt and dx dt. So let's do that. So we are going to differentiate, right? Differentiate 3L equals x with respect to t, both sides. So then we have this. 3 times dl dt equals the derivative of x with respect to t is just dx dt. And we do know dx dt, which is equal to -5. Therefore, dl dt is going to be -5 third. Well, this is going to be feet, actually, the feet per second. Okay, so this is the first part. We already solved the first part. What rate of change of the length of her shadow, which is L, so dl dt is this guy. The next question is, at what rate is the tip of her shadow moving? So again, in other words, this is the tip of her shadow. It will be moving towards the straight line. So basically, it will be dw dt, right? So in the notation that we have, dw dt, that's what we want to find. And we do see that w is equal to L plus x. Okay, L plus x. And then you see that x is actually equal to 3L, which means L plus x is 3L. That's from above, right here, from above, which is equal to 4L. So therefore, dw dt is actually 4dl dt. In this case, we do know the dl dt at that moment, which is -5 third. So 4 times -5 third, which is -20/3. So this is how I would interpret this question and how I would solve that. If you use the question, the help me solve this option, it actually explains like the tip of her shadow moving is equal to the sum of the shadow and the rate the woman walks towards the straight line. And why is that? I would like to explain that in a little more detail. If you look at this relation, w equals L plus x, which is pretty obvious using the graph, dw dt should be equal to, so I'm going to just differentiate with respect to t using this equation, okay? So it's going to be dl dt plus dx dt. So that's why you're adding the length of the shadow, the rate of the length of shadow, plus the rate of this woman walking towards the headlight, the straight light. So that's the reason. But you can do it that way, or you can do it the way that I just did. So this is it.